All right. Before I get started, I do have to say, Adrian, love your hair. Kind of hard to follow up on. Okay. With that being said, hello everybody. My name is Daniel Olshansky. I'm a protocol specialist, primarily focusing on consensus work at Pocket Network. And today what I want to do is talk a little bit about the design decisions that went into Pocket Network v1, which is the next version of the protocol, and give you some insight into the design decisions that were made and the headway that our team is currently making under right now. So firstly, here's a high-level agenda of what I want to cover. Firstly, I'll talk about what Pocket Network is. Then I'll compare how the v0 stack compares to the v1 stack. v0 is out in the wild, and v1 is underway as we're speaking. Then I'll talk about why we're moving away from Tendermint, which was a very interesting decision and a lot of interesting details that we can cover there. And then I'll give you a very high-level idea of what we're doing with the consensus, the utility modules, because there's a lot of really cool stuff that's happening there as well that I'm very excited to share with you guys. So, if you don't already know what Pocket Network is, it's a Web3 infrastructure middleware protocol that provides a decentralized multi-chain RPC layer. That was a mouthful, but what does it actually mean? So if you're a dApp developer and you need to access and read and write data to a blockchain of your choice, you have a few options. You can either run your own node locally on your own server behind some authenticated endpoint, or you could potentially be using some sort of centralized provider. What Pocket Network does is solve that problem. There's a lot of articles and conversations and people discussing on various podcasts how we have this beautiful decentralized Web3 world behind a centralized Web2 gateway. The way Pocket Network works is, as an app, you stake some POCT, our native cryptocurrency token, and then you start making requests that we normally would with any other option that I just mentioned earlier. On the back end, our network matches you with a few nodes. So whether you're working with Ethereum or Solana, we match you with a node that supports that blockchain, forward your request, and get your response. Ultimately, what that means is you get a decentralized, secure service, regardless of whatever protocol you're building your app on. Even more importantly, and I'll touch on this in a moment, is the incentive mechanism that we have for node runners to be Pocket validators, as well as run full nodes of other blockchains in the crypto ecosystem. So now that you kind of know what Pocket is, where is Pocket? So Pocket, we have nodes all around the world, and as of this week, we're handling more than 2 billion relays a week. With more than 2 billion relays a week, supporting more than 40 different blockchains on our network, and we recently just crossed the 30,000 node mark. To put that number into perspective, Bitcoin today only has 15,000 full nodes on their network. We have twice as many, and we're supporting many different blockchains to make sure that developers are able to get the best service as they're building their app. But what's even crazier is not where it is, but where it's going. So if you look at the number of active nodes, it's 3,000. The year-over-year increase is 3,000%. If you look at the number of average relays, it's up 5,000% year over year. But how are we getting there? Like, there's so many nodes, so many relays. What's the real incentive? Well, what's driving all of this growth is that our rewards. It's financial incentive for validators to run Pocket nodes alongside other full nodes of other blockchains, and applications get a very high quality service at a cheap price by staking POCT, which is how we also reward the node runners in the network. So now that you know what Pocket is and where it's going, if you're running a Pocket node on your server, let me ask you, what's in your wallet? No. What's in your Pocket, guys? Well, it's actually very simple. I can tell you what's in your Pocket. What's in your Pocket is it's an ABCI application, and all that means is that we're built on top of Tendermint, and we use the interface that Tendermint exposes in order to leverage their consensus engine along with their peer-to-peer and persistence layer. So the only difference that we have from other applications built in the Cosmos ecosystem is the fact that we had to fork Tendermint a couple of years ago. The reason we did this is because we had to customize the leader election protocol. We had to make some customizations to the persistence layer so that our node runners have more efficient usage of their resources. And we had to make some customizations specific to the utility of the Pocket protocol. So what's in your Pocket is a forked Tendermint version from 2 years ago. Of course, we've been backporting some changes. Of course, the ABCI application that makes Pocket what Pocket really is, and all the other blockchains that you choose to support on your node. So there's more than, I believe that we have more than 40 nodes right now, but you can support whatever subset you want. And here I have Harmony, Ethereum, and Polygon. So the network is growing, the numbers look great, and everything works. So why should we be changing anything now? Well, Cosmos SDK and Tendermint was a great way for us to get bootstrapped when it was a small team with not a lot of runway and there was no product market fit. We really had to learn, what are we building, why are we building it, and how do we build a community around it? And now that we've passed that stage and the team is much bigger and we have more runway, we're thinking ahead. We want to be able to support an uncapped number of validators, support trillions of relays a day, and not sacrifice any security or any decentralization while doing so, while still providing the fastest latency possible for applications. All of this sounds great, and it's exactly what we're thinking about as we're speccing out V1. Now, one of the other big things, and I'll dive into more details about this in a moment as to why we're changing things, is we are hitting real scalability issues. As you can see on the screenshot, this is from the Tendermint docs, where it was built and designed for 10,000 validators at most. This was okay 3 months ago, but today we have 30,000, and we really are hitting the limits of what Tendermint was built for. So that is why we're changing things, but we're not recreating the wheel from the ground up. We're really learning a lot from how Tendermint was designed, specced out, and we've taken a lot of inspiration from their engineering efforts. V1 is split into 4 core modules. We have the utility module, the consensus module, the peer-to-peer module, and the persistence module. I'm going to touch a little bit on the details that are in utility and consensus, since that's where most of my work lies, but it's worth mentioning that there's also a lot of interesting work that our team's doing on both P2P and persistence. In addition, even though we're building everything in-house, it doesn't mean that we're recreating everything from scratch. We've been doing a lot of research, looking at peer-reviewed, formally verified literature, and we're taking all the bits and pieces from different places, customizing them to our needs, and that is how we're speccing out Pocket V1. The other really big benefit from doing things in-house is having really tight inter-module integration. So we're using literature that was published in the last couple of years, but we're able to optimize everything for Pocket's specific use case. The one big thing you see here is we no longer have Tendermint and Cosmos in our stack. And what I want to say is, even though it's not on our roadmap right now, it doesn't preclude us from being IBC compliant in the future. It's just another protocol, it's just another interface, and it's something we can potentially support in the future. So I already touched a little bit about the scalability issues that we've been hearing with Tendermint, but leaving such a mature and battle-tested framework with such a large and growing ecosystem is not an easy decision to make. And we discussed this extensively, and I did challenge this as well within our team. But as you will see shortly, this really does make a lot of sense. Now, when I wake up in the morning as a consensus engineer, working on sexy and fun things like safety and liveness is exactly how I want to spend all of my time. But when I recently did a deep dive into the Tendermint code base, the amount of engineering effort that went into something as simple as state sync is immense. It's something we take for granted. It's something that's going to require a lot of work, but it is still something that we're going to be able to do, and it is a cost that we're willing to take. Now, the reason we're doing this is, as you can see in this Tendermint in a nutshell info diagram, is We want to modify the consensus algorithm so it's easier to understand and comprehend. We want direct access to the mempool. We want to modify the leader election algorithm. We want to optimize everything for pocket-specific use case for all of the reasons I mentioned earlier in the presentation. And if we keep trying to fork Tendermint and merge things back in and have all this support while working on a very large, mature legacy code base, this is simply infeasible. So now that we're moving away from that consensus protocol, what were the considerations that we took into our new consensus protocol? Well, firstly, we had to decide, do we want probabilistic finality or immediate finality? Like many other proof-of-stake blockchains, especially if we want to remain IBC compliant, we need immediate finality, and this was a pretty easy decision. What this means is that we're going to be ruling out Nakamoto consensus, and we have to stick with Byzantine fault tolerance. There's a lot of different BFT algorithms out there, and the reason I have 3 different charts, all basically showing the same thing on the board, is because in different papers, depending on the assumptions that you make and the lens through which you view them and how you test them, there's all the different you have different forms of complexities associated with each BFT algorithm. However, they all point to one thing. They point to the fact that hot stuff is one of the leading BFT algorithms out there in almost every single way. It has linear complexity. It is responsive, which means that it moves at the speed of the network. It has linear complexity, it's responsive, and it's very easy to understand and customize, as you will see in a moment. So, now that we know that we want to go with a hot stuff BFT algorithm, what else are we going to do? So we take basic hot stuff. Basic hot stuff is one of the variations of the hot stuff algorithm, which was driven by the Libra DM project. We're taking cryptographic sortition from Algorand, which essentially gives us a verifiably random leader election algorithm in V1 of Pocket Network. And one of the other things that we need is a distributed key generation and threshold signing library. We're still exploring a few different options from a few different frameworks, but we're currently leaning towards using Frost, which is being researched by the Zcash Foundation. Now, you take all of those different ingredients, you mix them together, and that is how we serve you hot pocket consensus. It is hot, it is blazingly fast, and that's what happened to me when my hair caught on fire while working at home. So I'm not going to dive into all of the details of how basic hot stuff actually works, but what I want to point out here is it's so simple. It's linear. There's no more meshing, no more nil voting, no more gossiping. It follows a star pattern with linear complexity composed of 4 rounds that is very easy to reason about if you just sit down, read through a paper, and spend a couple hours on it. However, after jumping and looking at the research and looking at all the details, this is when theory expectations started meeting reality. And what happened is that at the time that the paper was published, there was no good threshold signature library out there. And I was wrecking my brain over this, trying to understand what is going on. The reason this is a problem is because threshold signing and distributed key generation each takes several rounds of communication throughout the entire network. What this means is that you would take the linear complexity of the algorithm and make it quadratic. And this is where the power of building your own blockchain reactor and your own consensus algorithm from the ground up really comes into play. This diagram is just for illustrative purposes, so don't take all the colors and the arrows as scientific proof. But what I'm trying to show is that when you build things in-house with your own consensus algorithm, we can leverage this linear star pattern to disseminate information throughout the entire network without taking the cost of quadratic complexity. So whether it be for verifiable leader election or distributed key generation or any other metadata, since we already have that dissemination of information throughout the entire network, we can just tie additional metadata to every single step and the entire network will know about it. And that is hotboxing consensus. Now, jumping quickly into our utility module, there's a lot going on this slide, but what I kind of want to say is the way things work right now is that you have a Pocket validator or servicer, which essentially relays requests from the application to the respective blockchain that they're hosting. What this does is it solves the problem. You have a decentralized RPC infrastructure. We have a really good economic model where basically all of the validators are incentivized to support as many blockchains and provide as good of a service as they can. And there's a lot of really novel zero-knowledge proof work that has proven itself over the last couple of years. The big problem with this is that there's no way to guarantee on-chain SLA. So this is where the utility module V1 comes in. The big thing that I want you to note is that the difference between V0 and V1 is that little fisherman at the top right. What the fisherman does is periodically, during a session of servicing relays, continuously samples the servicers that are replying to the app's requests. What it does is checks for consistency, data integrity, and latency, and then basically takes a report card and posts it on-chain regarding how well each servicer is doing. So in V0, we have inflation that is based solely on quantity. In V1, we have Pocket inflation rewards that are based on both quantity and quality. And if you have ever built a Web2 service, you've probably seen the 4.9 guarantee, the 4.9's SLA guarantee from AWS or GCP or Azure. What we have in Pocket Network is an on-chain SLA, which pretty much says that you get rewarded and your service is a function of how well you're doing and how quickly you're doing. And I don't have too much time to get into the other details, but on the bottom right here, you see a diagram where we can compare Pocket V0, not V1, to some other centralized services available today. And we're not only competitive in the P50 and P90 latency, but we're in fact doing better while not sacrificing for decentralization and being a multi-region, multi-crown service for the ground up. Last slide. One thing I really want to say is that I've been following Pocket since the early days, but I officially only joined 3 or 4 months ago after having the privilege of going to their offsite in Mexico. So far, this has been one of the best experiences I've ever had, and most of the work that I presented here is of this team that you see here, some people that you don't see in this photo, and the community that's involved. I've really never been part of such a small and motivated team where everyone is so excited and passionate to bring the true vision of Web3 to fruition, where everyone is both challenging each other every single day, is supportive of each other every single day, and I still wake up happy every single morning knowing that this is what I do full time. So if any of this intrigued your interest, follow us on Twitter, join us on Discord, or just come say hi to our team throughout the rest of the conference. Thank you.